Hi everyone, I'm going to show you some techniques you can use to memorize a randomly generated password. Randomly generated passwords are generally more secure than anything a human can come up with because humans tend to think alike and that can be exploited. However, in most cases you probably don't need to memorize a password. Just use a password manager instead. I use KeePassXC, I like it. Another option that you can look into is, for example, Bitwarden. Now, cases where you may want to consider memorizing a password are cases in which you access the well, first of all, you have very private information on it and you access that information quite rarely, so you don't get a lot of practice, and you want to make sure that you remember the password. Maybe you're using the password as part of your passphrase to protect your Bitcoin. In cases like that, it could be useful to make sure that you have it properly memorized. Now, I would never ever only store a password in memory. I would always have a physical backup somewhere. Memory can always fail. You will never memorize this 100%. However, physical backups can fail as well. They can become destroyed or inaccessible. So the way I think about it is that combined, they are better than separate. The probability that you're going to lose both is going to be much lower than the probability that you're going to lose either one. And then finally, one note about security. I'm going to be demonstrating all this on my daily driver, and you may not want to do that if you're concerned about keyloggers and that sort of thing. If you're actually going to use this password for something, I'm just going to memorize this password for demonstration purposes. They're not going to be used for anything important. And the safest low-tech way to probably do this instead is to use pen and paper. But if you do want to use a computer to implement the techniques I'm going to show you, you could look into something like TailsOS. Let's start by creating the passwords. I'm going to create them in KeePassXC. Each password is going to be 20 characters long. I'm going to create 3 of them in total. And now the question is, how are we going to remember this? And I'm going to start by using a technique called fading. It was developed by B.F. Skinner. And there are many things you can use fading for, but one of them is memorization. And I'm going to give you an example of that from his autobiography, A Matter of Consequences, where he helped his daughter memorize a poem. So here's the paragraph in which he described what happened. You can pause and read the whole thing if you're interested, but I'll just summarize it. He helped his daughter memorize a poem by writing it on a blackboard, had to read it out loud, then he erased some of the letters, and then she read the whole thing again, even though the poem was incomplete. He erased some more letters, and so on until there was nothing left on the board, and she knew the whole poem by heart. And we're going to do this to the same thing to kickstart our memorization of these 3 passwords. I'm going to implement the fading technique with a script that I've written in Python. So here's our password, and I'm going to set the fading parameter to 3, which means that every time I type the whole password correctly, it's going to remove 3 characters. And I just kept doing this until I had completed the whole thing without anything being written in the prompt. I did this once a day for 3 days for each password. And after that, I definitely knew the password, so I switched to a rehearsal exercise instead, in which I would just write the password 3 times with 5 seconds delays between, like this. So let's take a look at the data we generated from these exercises. Here it is. Here's the fading data, and here's the rehearsal data for all passwords. So as you can see, for the fading data, I got faster and faster at completing the exercise for each day, and that made me determine that I was ready to move on to the rehearsal phase. And in the rehearsal phase, you can see accuracy and latency. Latency is just the number of seconds it took me from seeing or being prompted to enter the password until the time I entered it. And now the question is, how do we assess progress based on this data? We're going to assess progress by plotting the data on a semi-logarithmic chart. So we have frequency on the y-axis, which is logged, and a linear x-axis. And you don't need a fancy chart like this one to do this. You just need any logarithmic chart will do. I have certain standardized dimensions for this chart. This is something used in an area called precision teaching. I'll put a link in the description if you're interested in learning more. It's called the standard acceleration chart. But all you need really is a logged y-axis. And here we have the fading data. So here we started fading, and I measured the time it took for me to complete a fading exercise. What counts as a completion is me being able to write the whole thing without anything being written in the prompt. And as you can see here, I'm getting better at it. And you may wonder, why is this thing going up? It should be going down. Well, I am representing all this data as a frequency, so I'm representing it as 1 over the number of minutes it took me to complete the exercise. And here's me switching to the rehearsal exercise. And here I'm plotting the correct frequency of corrects as dots and frequencies of incorrects as x's. And as you can see here, like this straight line here, we can see a straight line in the beginning and then a sort of flattening out. And what I want to advocate is that you make a data-driven decision about when you're done instead of having some general theory. What will be the same for you is the straightness of these slopes in the beginning when you learn. I cannot predict the inclination of the slope, but if you're doing this correctly, you will have a straight slope of some kind. And I cannot tell you when it's going to stop either, but when it starts flattening out, you know that you personally can stop. And the criterion I used for having completely learned the password was when I could emit this at a sufficiently high frequency without any errors. So this is what happened here, you see. So I had 4 data points here. My threshold was 3, actually, where I was able to emit this at a high frequency without making any mistakes. And this is what they in precision teaching called fluency. That is accuracy plus speed, not just accuracy. And here you see I set my fluency criterion, which is me just taking the last 3 data points and subtracting 10%. And I'm going to use this for defining at what frequency that counts as fluency for me. So when I learned to retain this password, which I'm doing here, I waited a certain number of days. Every thick vertical line here is a Sunday for reference. And then I did the password again. And my goal was no errors. And I wanted to be able to push it above this line. And for retention purposes, that is what you can do. You can just wait a certain number of days and then push it up again and again and again. It's going to get easier and easier. I cannot tell you exactly how long you should wait, but I would wait just a little bit in the beginning, and then I would wait longer and longer. But here's how you can make data-driven decisions about when to stop and when to rehearse and how much to rehearse. Here's the other password that I practiced. And as you can see here, sometimes your data will not be that orderly. This is a bit more variable, but the concept is the same. So here are some potential concerns. Someone might say that this is too much work. Well, first of all, I would just ask what kind of information is your password protecting, and that should probably answer that question. But I would also point to the total amount of time I actually spent practicing these passwords. Yes, I learned them over the course of 2 weeks, but about 2 weeks anyway. But the total amount of time I spent on learning them was not a lot. Here are the total amount of minutes I spent in the fading phase for each password, and here are the total amount of times I spent in the rehearsal phase. And as you can see, if you add them all up and take an average, it's not a lot. Someone might also argue that charting is too much work. I would argue that it's going to save you time because, first of all, if you chart it, you're not going to have to do any math. You can just eyeball it. And second, when you do chart it, you will know when to stop. So that will also prevent you from wasting time. I think there are multiple aspects about these techniques that can be improved. For example, the fading should probably not take 20 minutes. I think it might be possible to decrease it even more. And another thing that I'm not too sure about is whether one could do the retention practice in a more organized way. For example, by drawing from a power law distribution to select the number of days one would wait. But that's just a geeky question for me. I don't think it's ultimately necessary for practical purposes, but that's one thing I'm wondering about. Finally, if there's any interest, I will post the scripts that I used on GitHub, including the code for the chart. And that's it for me. Thank you for watching. I will see you in the next video on seed phrases.